This conference will now be recorded.
Sorry, guys, I forgot one important thing. But please continue, Steve.
All right, thank you. Yeah, so to the left of the UPS in the middle there, we've got an air-cooled pod, and then to the left of that, we've got a rack-based full immersion liquid-cooled pod. In the roof section is the cooling units. And then you've also got all of the security and all the added functions you would expect in a traditional data center. CCTV, intruder alarm systems, access control, fire detection, suppression, etc. Now, why do we do things in pods? So a couple of reasons here. Number one is it allows us to expand the module at any time. So in essence, we take the cladding off of one of the ends, and it can be either or both, and we extend the module by adding additional pods that can contain either IT infrastructure or electrical equipment. If you run out of space, you can put corner sections or curved sections in order to snake, we call it, around existing infrastructure. So we can change the shape. So if you think about it, you don't have to go in a straight line. You can create a capital C type shape or a capital E, for example. The other reason we do stuff in pods is it creates we create a microclimate, which means that each pod holding IT equipment can be configured individually. So I mentioned we have an air-cooled rack here, and we have a liquid-cooled rack. So in the liquid-cooled rack's case, there is no air cooling requirements, therefore there is no air cooling. It's just 100% liquid cooling, and that gives us great power efficiencies. And we'll touch on that in a sec. In addition, we do access control by the pod. So in an example, if I had a UPS engineer visit site, I would only open the front door of the middle pod. I don't open the rear doors. I don't open any of the other doors. And that means that that engineer can only see, touch, or feel, get anywhere near the infrastructure that he's allowed to get near. So, he's not entering a large shared data hall, for example, even though there might be some rack-based security. So we've got enhanced security. From a fire detection and suppression perspective, we also do that at a pod level. So, we've got FM200 gas suppression here. If there was a UPS issue, the gas is released. Because there's no human space, we can hold the gas to prevent reignition inside the pod. When it's safe, we evacuate the gas and we allow the emergency services to do their thing. The added benefit of being pod-based is even if there is an issue in one pod and the gas is released, all of the other pods remain 100% protected, and they have their own gas suppression. So, you maintain absolute protection at all times. There's a high degree of insulation on all sides of the pods and also fire protection. So, that can be configured based on customer requirements. Default, it's a minimum an hour, but it can be 2, 3, whatever people want. From a cooling perspective, we support all of the cooling methods that are on the market today, be it air-based, liquid-based, etc. Where you are footprint constrained, we suggest we put the cooling units on the roof section, and that has the advantage of putting the cooling units as close to the heat source as possible. Again, energy efficiency there. But if you are height constrained, let's say you're going in an existing building or structure or underground car park, then we can use in-row or end-of-row cooling technologies. And the beauty of our solution is that you can mix and match those cooling technologies. As I said, you could have air-based technology, liquid immersion cooling technologies, and DLC type technologies all in the same module. You can also vary the cooling capacities. So, again, to be maximum efficiency from an energy perspective, if you want 5 kilowatts of air cooling in one pod, that's all we allocate. If you want another pod that's 20 kilowatts of air cooling, then you allocate 20 kilowatts of air cooling to that pod. And so we flex and adapt the cooling to meet the internal requirements. In general terms, air cooling we do today up to 30 kilowatts of rack. Liquid cooling we could do up to 100 kilowatts of rack. Just jump forward 2 slides. Why do people buy from us? So we're quick. Right, our time to market is 6 months from purchase order to delivery. That's delivery, installed, commissioned, handed over, and fully operational. The closer we are to our manufacturing facilities, we can do that quicker and smaller units. But obviously, as we start scaling up to larger deployments, then we're at our 6-month timeline. Compare that to traditional builds, you're looking at 18 months or even longer. You know, those that are familiar and doing work in Ireland will know that the planning process and the challenges around grid energy capacity means that 18 months would be a bit of a miracle at the current time. CapEx can be significantly reduced, so not only because we've removed all of the human space, don't forget this is designed for edge, although it expands to multi-megawatt scale. You know, you only need to buy what you need. It's very efficient from a cost perspective, you know, and it means that you can keep that CapEx low, particularly when we come to edge, where you might not know what the new technology is going to be around. Buy what you need, have it built to what you need today, so air cooling or liquid cooling or a mix. You need to expand it in the way that you need to. So, for example, if you're adopting new kit from AMD and Intel, you're going to be wanting to be able to have a solution that accommodates for perhaps a kilowatt a U, and therefore you're going to be needing 20, 30, 40 kilowatts of cooling per rack. Now, traditional colos that are still being built in the 5 to 7 range, you know, are going to struggle to meet such requirements. Flexible and scalable, I kind of touched on this. Expand it as you need to, you know, scale it when you need to. You can add power, cooling, or IT space, you know, independent of each other and on a running system. So we don't need to shut the whole module down to add extra capacity. Today we can fit 8,000 plus cores in a single rack. We expect the new chips by the end of the year to be pushing 12,000 or greater. Everything we talk about in data cube terms, we can do indoors or outdoors. So in the outdoor units, they're obviously highly secure. They're designed to be outdoors, fully IP rated, etc. But all of those design features into indoor versions, which, you know, the pod-based approach to create microclimates to allow variation in cooler capacities and types and power capacities and types, etc., and bring all those energy efficiencies that come with it. From a sustainability perspective, we've got some great stats which have been independently verified and audited by external third parties. But we compared traditional builds of bricks and mortar to our external version, and we can reduce embodied carbon footprint and associated build greenhouse gases by up to 50% in both cases. That's just the build process that excludes OPEX stuff, which I'll touch on in a moment. And because of the microclimates and the way that you only adjust, you know, you only open doors to pods that you need access to, you can maintain the internal environment at a much greater granular level, which leads to things like increased component lifespan. So again, this helps the sustainability approach, because if you can expand, if you can have things like your UPS batteries, your lead acid batteries last an extra 2 or 3 years, then that's good news for the environment. Now, when we talk about power consumption, this is where we can really make a bit of difference. So everything we design, regardless of location globally, we design for a fully air-cooled system to have a PUE of 1.35 or better. If we adopt liquid cooling, we can go down to as low as 1.03. And as I mentioned, because you can have different types of cooling in the same module, you can easily land up with a hybrid, but you're never going to exceed 1.35 based on, you know, 2-year plus of weather data. And this applies even in hot countries or humid countries. And this is because A, we minimize the amount of space, we use more but smaller cooling systems, so we can run them at a lower utilization levels. We put cooling systems, for example, as close to the heat source as possible. All of these factors we add up to really good PUE metrics. And of course, what this also means is that we can get great power reductions and efficiencies, even if the modules are only part populated. So, you know, if you imagine, if you built a data hall, traditional data hall, or even you buy a containerized solution, as soon as you put the first bit of IT equipment in there, generally you're cooling a significant chunk of the space, or maybe even the whole space, regardless of unoccupied areas. With DataCube, you can disable the cooling for unoccupied pods, because we do all of this cooling by the pod, and we can adapt the power by the pod. If you've got a pod that's unoccupied, don't cool it. It's as simple as that. Save yourself some power consumption. So from an infrastructure perspective, we can reduce power consumption by up to 40%. If you go liquid cooling, then we can reduce that even further. The other point, as I'm sure everyone on the call knows, right? If you adopt liquid cooling in these facilities and you've done it at sufficient scale from a power perspective, we have the complete ability to capture that waste heat and repurpose it for heat recovery purposes. And we're working on lots of different solutions. Anything from we're just doing some design work for somebody who wants to heat public swimming pools and public service areas, and with the waste heat, we've got other projects we're working on, which involves hydrogen plants, where we're going to use the hydrogen power to power the module, but then use the waste heat to help with desalinization to provide water back to the plant. So there's lots of different use cases that we want to get involved in, because we really see that liquid cooling and heat recovery as a tremendous advantage and makes us very unique in the marketplace. I'm going to whiz on a couple of slides just to pause through some of these marketing ones, just to the end, really, to show that we can, provide a completely turnkey solution. So we provide absolutely everything. If people want us to provide the generators and transformers, we can do all of that. We can sort out all of the foundational requirements, because even for DataCube, we have a very sustainable approach to the DataCube solution and how we can create a base. So we don't need huge volumes of concrete to support an external DataCube, for example. We can reduce people's capex. We can get them to the market faster. We provide them with tremendous flexibility and scalability, and we have great power efficiencies. One thing I've neglected, because I brought up the wrong slide deck, we've just done, if I scroll all the way back to this here, where we did the cutaway of the Cambridge module, I mentioned in this particular instance, because it's all rack-based pods, we can do full immersion using LCS, for example, here. Or we can do DLC type technologies or air-based technologies. Of course, there's a gap that people might say is, well, okay, what about tank-based immersion? Because there are a lot of very good manufacturers out there that do tank-based immersions, and we have just completed hot off the press design work to allow us to accommodate tank-based units. And if you can just give me 1 second, I'll change to another presentation to show you what that might look like. I was all prepared as well and opened the wrong one. How am I doing for time, Carl? I think I'm okay. That. Right page.
Yeah, so far there's definitely is a very interesting approach, and I think really really interesting to make it scalable, for all, and a perfect technology at this point where there's a race between immersion and direct liquid cooling and still air cooling, and I think we will see a lot of hybrid approaches that usually are in facilities that are either optimized for air or liquid cool, but not both. So I noted down some question in the meantime, but now please go ahead.
Yeah, I'll be very quick for this one. This is hot off the press, so it's all confidentially shared. But so we've done a POC model. It's low capacity, 25 kilowatts, but it's designed to be small and rapid deployments. And this is for people who want to POC tank-based immersion solutions. And of course, they could do the same with rack-based that we've shown on previous slides. But we have a pod that's full of the infrastructure. Again, it's still tier 3, so dual power, distributions, UPS, N+1 on all the cooling. And you can put, we're aiming to be agnostic to the tank-based immersion cooling. So it doesn't matter which vendor you want to use. We'll provide agnostic connections for power and cooling, so that you can use it, or for heat recovery, of course. And from our perspective, we become generic, so that if you want to expand to larger capacities, so 100 kilowatts, we have to put in larger UPS systems. So we get up to 100 kilowatts, maybe still in a single tank-based solution. And then if you want to scale up to even further, you can have 2 tanks, obviously still 100 kilowatts from a power perspective, or indeed you can go up to, here's an example of 200 kilowatts. We have larger switchgear infrastructure, same size UPS at this level, and we can have 2, 3, 4. The advantage with us, obviously, even if you're using tank-based immersion and it applies air, rack-based immersion or DLC cooling, you just add the pods that you need. So you could start off with one tank, size your infrastructure to the left as you need to for your future requirements, but keep your costs down. When you want to buy a second tank or a third or fourth or fifth, you can add those as you want to. And of course, yeah, coming back to, you could mix and match. You could have rack-based immersion, DLC, air, and the tank-based solution all in the same module if we really wanted to. So I'll pause there. It's a nutshell. Happy to have breakout sessions, go into deep dives of anything. If anyone's got any questions, I can take them now if there's time permitting, or later.
Yeah, so in general, you know, the idea, and that's why I'm happy we have this super critical and experience group here. So the idea is to take the old format of the traditional specification and to create a document that we can contribute to the OCP, showcasing the different modules, how they work together, you know, in all the shapes, and maybe the whole alphabet would be nice. But to really, you know, now see to grill Steve a little bit on why this should not be within the OCP. I think I personally think it should. There's some questions and some for sure some considerations that need to be there if we look at OCP technology, you know, DC, busbar, power shelves, all those things. But in general, I think this is good. So I'll start with the first question, which is on here when you said like the 5G enabled. Is that a private 5G setup to communicate between the modules, or can it be also external and so to speak both?
Yeah, there's different solutions based on the country of deployment and customer requirements, but we effectively can support 5G technologies. Now, that could be in partnership with an MNO to provide cellular capability, or we work with a couple of different providers to provide 5G private networks. You know, when it comes to this kind of stuff, we call it out connectivity. Even a lot of the products that go within, we're vendor agnostic. It doesn't have to be UPS manufacturer X or 5G communications company Y. You know, we can work with anyone. We're happy to interchange the technologies. We've got partners we work with that on the communication side can provide seamless cutover between fiber and air-based technologies, 5G, satellite, whatever. But we can, if customers want us to, we can provide 5G private networks, UK sovereign cloud, and many other.
Yeah. Okay. Yeah. Thanks so much. Yeah. So the floor is open. Any other questions for Steve right now?
Herb Zion here. Of course, we've been working with DataCube for a number of years because we really like the flexibility of the system. The ability, frankly, to be small, large, tall, short, big. I mean, it's just incredible. And of course, as Steve said, you're able to put different technologies in each pod. So it's amazing. We prefer our rack-based immersion technology. I can't imagine why anybody want to put tanks in these things, but I guess they can accommodate that even still.
No, we obviously have to. With the OCP, the difficulty is to have that wide head, you know, and to look at all the technology. But obviously, I think that's one of the strong suits of this technology, that you can choose even between rack-based immersion and tank-based. You know, whatever. Customers are crazy; they bring everything to their liking. So to react at that, you know, from a co-location service provider, I think is unique.
Well, customers are crazy, but they're always right.
Yeah, you're right.
For us, it's about trying to encourage people to adopt new technologies. You know, there are you know, Herb's got some great rack-based immersion technologies. If you want to do crypto mining, you're probably going to stick it in a tank, right? So there are different use cases here. Now, whether, you know, crypto mining in a JCube module is the right thing, I don't know. We'll leave that for a debate another day. But you know, anything, we see the adoption of liquid cooled technologies particularly as super critical for making data centers more efficient and more sustainable. Anything we can do to push people in the right direction, be it rack-based or tank-based, you know, we're fans of that. We've obviously got our own personal preferences, but whatever we can do to help customers start adopting that technology, the better.
Perfect. Other questions for that? I'm trying to think of considerations or limitations, but you've worked on this. You, obviously.
I
have just one short one.
Yeah.
It's not really that serious, but just in terms of clarification, when you say tier 3, that's just in terms of the power, right? You have redundant and concurrently maintainable power supplies. That's what the tier 3 is referring to, not the cooling.
It refers to everything. It's concurrently maintainable infrastructure, so we would have that applies to power distribution, including UPS and the cooling. And even so, just to clarify, when we're talking about liquid-based cooling as well, so either any of the liquid cooling technologies to be tier 3 compliant, that means you have to have concurrently maintainable feeds of the cooling to the rack. So it's 2 complete systems of fluid flow and return into the rack infrastructure, the same as you would an A and B power feed.
Okay, thanks.
Okay, great.
I have a question. Is this the immersion? Is a single phase immersion or a 2-phase, or does it make any difference from your side, from the whole pod's design?
From our perspective, we you know, I mentioned we've got our personal preferences as to, you know, what we feel is the right technology for different use cases. But at the same time, we're trying to remain vendor agnostic. So, you know, we can support both single and dual phase. But the example,
well, speaking for LCS, we're worried about the long-term effects of 2-phase, and we don't think, frankly, it's needed for almost any application.
It's certainly not something we're seeing much of. You know, rack-based, you know, it tends to be LCS for us. Tank-based stuff, again, you know, it's the usual vendors. They're all single phase.
Okay, nice. And 100 kW, this is, you think, the limitation of a single phase in this tank, or it could go more?
I think it's just where broadly the current technology limits are. Right? You know, we have to factor in it is not just necessarily the ability to cool 100 kilowatts of liquid, you know, or the hot liquid coming out of 100 kilowatts of IT. You've got to factor in the availability of enough IT infrastructure of significant power to use that. But at the moment, we can do up to 100 kilowatts. We expect that to rise over time.
Mm-hmm. Thank you.
Okay.
And just
Right.
one comment, I wasn't sure whether I was clear from an Uptime Institute tiering perspective. We can design to any of the tiers 1 through 4. You know, to give you an idea, we've just done a 0.5 megawatt design for Africa. It's all DX. It's sub 1.35 PUE, and they're getting a tier 4 design for less than the cost of a traditional tier 3 facility.
Thanks. I mean, I asked the question because I was gonna follow it up with like questions about space and maintenance and stuff like that. But I didn't want to take over the discussion. But I'll contact you offline.
Please do. Thank you.
No, but that's exactly right. Thanks, Jabri. This is exactly right to really question this a little bit, see, you know, if there are flaws in that, and then to see really can we move forward with this. But you know, I'll think that for me it's clear we have seen that.
I'll ask
working.
one. I'll ask
Okay.
one.
Yeah.
Do you have redundant RPUs, or is it redundant piping? Oh, sorry, redundant pumps inside the RPUs, the reservoir pumping units for the single phase coolants?
Yeah. So that's So the answer to that question is based on A, customer requirements, and two, the tier, B, the tiering requirements. But if you wanted tier 3, we would go redundant expansion vessels, pumps, pipe work. It's full A and B feeds to the rack.
Okay, all right, thanks.
A single flow and return into a liquid cooled rack, Uptime Institute would say that is non-compliant.
Sorry, could you repeat that last part?
So if you've got a single flow and return of your liquid cooling into a liquid cooled rack or tank-based immersion, the Uptime Institute will classify that as non-tier 3 compliant because you've got
tier 3
failure.
Did you have any pushback from the suppliers in terms of some of them, in my experience, they've said that there's no need for it because of how they seal their systems and stuff, and you're just adding extra pipe for no good reason that you're never going to use, and that kind of stuff.
Yeah, you know, there are two sides to it, as always. So from the Uptime Institute's perspective, obviously I'm not talking on their behalf, but we've had lengthy discussions with them. So if you imagine to be tier 3 compliant on a power perspective, you have to have an A and B power feed into the IT rack. So you have, so you can switch one of those feeds off or one of those power strings off, and the IT will remain up. The same holds true for liquid cooling. They insist that you should have separate A and B flow and returns into the rack. Now, if your liquid cooled solution doesn't require an A and B feed, then obviously you can then, you know, either combine those two feeds into the rack into a single one using a manifold or something to give you a single supply into your liquid cooled system. But for Uptime Institute compliance, you have to have two separate flow and returns into the IT rack. So what you do after that is down to you.
Okay, thanks so much for the feedback, and I will reach out to you to continue because I'm actually in another group with Uptime Institute, and I'd love to get your feedback on this.
Yeah, happy to. Yeah,
Thanks
lovely.
so much.
All right. Yeah, thanks. So I'm not sure how usually the last procedure is like. If there's any objection to Steve moving on DataCube Global moving forward with a specification, then it's your time to speak now. I think it's okay. We had our rounds of questions. There probably will be more, you know, in the final or in the review process. But I think this is something really different, especially since we, you know, or in the upcoming group, we will always try to, for comparability, have, you know, the base all-in-one form factor, you know, published by PCX and Schneider Electric, and we had other modules from Swedish modules, but this to the smaller end of modularity, up to, you know, scalability, I think is something very unique and a different way to approach this. So I'm excited to have that published and showcased here. Good. Steve, any last words?
I just wanted to thank everyone for their comments, questions, and thanks for the opportunity again. And I look forward to getting this onto the approved OCP ready.
Great, perfect. All right. I then, in the meantime, while I'm looking up the white paper from ZutaCore, a bit of recap. We have a couple of people who had been to the OCP summit in Prague. Alan, do you want to give a quick feedback from your input? Alan is not responsive, so I'm happy to explain, or I'm happy to give a little bit of my input. So overall, the summit was, I think, or what I heard from the OCP, they were quite happy. Was quite a huge step up after the OCP came back after 4 years in 2019. They were in Amsterdam. They came back, and it's comparably smaller. If you have been in San Jose, it's like a tenth. But the participation was really good and really interesting, mostly due to the energy crisis in Europe, with a lot of emphasis on energy efficiency. The Future Technology Summit also showcased some very interesting solution in terms of data center heat, data center location. There was a lot of research presented there. There were other options towards, heat reuse was a big group. Liquid advanced cooling solutions was a lot. We were able to give our presentations, which we talked in access prior to the summit. But overall, it was really good attended. We had four sessions in different work streams, 3 in data center facility, 1 in advanced cooling, and even where we were the last one in advanced cooling facility, it was very well attended, and we had a lot of really nice solutions there. So now let me share my screen. This should be especially interested for some of you. Share. Okay. So based on the 90 kilowatt module, SuterCore was creating 2 use cases which we want to combine in a white paper. They sent this to me. So based on the base dimension of the structure and base racks, I'll think those are 19-inch racks. We're happy to have also a presentation with 19-inch racks. The usual, fire protective systems, dedicated Dell hardware. No, sorry, Arthur. They choose something which is not your solution. And we also want to look closer into their cooling, what is needed for them to cool their liquid cooled racks. So the overview is with a comparably low PoE and a high density of 40 kilowatts per rack, we can reach an overall consumption of 480 kilowatts. SuterCore's air immersion solution, I think, is we potentially extend that in an appendix. I think it was not detailed part in here, but they do give us some calculations in terms of servers, server infrastructure, switch infrastructure, racks, the facility water construction in kilo dollar. And a complete system, including server, equates to 6.1 million. Quite a bit of cash. With a neat piping design here, showcasing how they have their PDU and their manifold for their air immersion solution. Sorry if the formatting is a little bit crooked. That is due to my use of LibreOffice. Should have transformed them with Google Sheets. Then usually you have the adequate setup. They're combining in-row cooling for the remaining air-cooled part. Obviously, the backdoor generator is here. All the components similar to the base setup with the central row aisle of the 90 kilowatt. They did, I think, several different location calculation. This one is obviously Arizona, as stated, with all the kilowatts needed, and then a yearly curve. Those calculations were done by David, who had to leave for the immersion cooling meeting. I'll still trying to find a slot where we're not conflicting in a lot of different things. There is a Odense calculation, so Northern Europe, with some details of the dry cooler performance. And I'm just wanted to, so this is the use case for a solution that is combining the use of a chiller and the use of in-row cooling. The alternative as a case of a case study is a bit more robust. So we wanted to combine the other use case, which is basically a direct liquid cooling approach where they have they cool off all the heat accumulated with the air immersion and put it via heat exchanger inside the server, if I understood correctly, directly outside. So there's no chiller, there's no water evaporated. This is quite a compact solution, which also therefore then leads to a very compact PoE. So as you can see at the module, there's only an air filter and then the IT. So all the heat is directly dissipated again into the air up to 40 degrees air inlet. So this means this is relatively robust to put somewhere and to place it even in relatively hot climates. So by eliminating the side row cooling, some of the air cooling components, there is the PoE is really low. The partial PoE, according to what they explain, is then around 1.01, which is extremely low. So those are the two use cases. What we need to do, obviously, is give a bit more context, put those use cases together, maybe have like a little bit of an explainer when to use what, but this is what we're trying to start off with SutaCore from now on to be able to have an additional white paper on liquid cooling technology. Potentially they're interested also in pitching a presentation, but first I wanted to create a white paper. Any suggestions? Any input we need to consider? All right.
Quick question. The 40 degrees Celsius inlet air, that was for a rack operating at what power?
So this, you mean how much power per rack?
Yeah, for when you're using 40 degrees Celsius air.
So that should be here. So I think we have 16 racks. So 350 divided by 16. I just wanted to see if I can, if they stated this here or if you calculated 15, about 50 kilowatts.
Okay, thank you.
Okay, no problem. Good. All right. Any other question? Okay, great. Daniel, was it? Do you wanted to ask something? Okay, then.
I just had to log off and back on.
Okay. Okay, so then the last item of business for today, you know, with 10 minutes left, is that we now we had a presentation on the modular data center hybrid cooling. It was nicely received. We had a good crowd. We had some good questions on what to do and how to use that. And we now start to move on to get the core group together to work on this off-site the MDC group meetings. This is driven by me and John Fernandez. David G agreed to do some calculation. We would love to have Philippe Boisvert or maybe and potentially another CDU manufacturer to be part of this effort. We want to highlight the calculations again with an efficient adiabatic solution. So John asked also Frigel if they could be part of that, which we also highlight in the liquid heat pipe or passive cold plate specification. Meta is kindly enough to sponsor some CFD analysis on the limitations of airflow and heat that we dissipate in that small form factor. We'll use and reference the advanced cooling facility white papers that were put out by John Grow and the following people in there. We need to, one item that we might can address here with Felipe is to reach out. You already said you're going to check back with Felipe. Maybe we can have a meeting together. Open to that. We'll should try and see if we can make it tomorrow because I know John is traveling soon. So we're going to start off those meetings and take the use to come up with a draft for the white paper until June, and then to have reviews and be able to put it into to present it at the global summit. What do we have? Yeah, we start with a case study, contributions. We also work with Rital. Here they were interested in supporting this effort as well. You stand here as WIP. I'm not sure what it stands for. Philip, I hope it's something good. But if you're here, if you can comment, and if you are interested in joining this effort, we would be very glad. I would be happy to say to John. And then we'll try to find a schedule for that off topic quite quickly. So it will be probably in the afternoon due to John's availability in the morning. Okay. Days of time. So we want to fix the Wednesdays 8:30s till 9:30s, or the Thursdays 8 a.m. to 9 a.m. To be able to do that, and we potentially start tomorrow on this effort. If you're interested, if you want to learn more about the native OCP direct cooling manifold, feel free to join or to contribute, and then we're happy to create another document within the MDC MDC community. Good. All right. With that, we have 5 minutes left for questions, use cases, any inputs for the summit. Some questions still here. Anything? Everything clear? Steve, I would connect you to Michael, Schill, and Rob so they can walk you through the license agreement. And I think you're already an OCP member, right? To explain you the right licensing. But then I think you're set to go off and work on the specification.
Great. Okay, thanks for that. Yeah, appreciate it.
All right. Good. Philip, are you able to comment on the cooperation with John Fernandez? I'll reach and send an email later. Don't you worry. Okay, Herb, I'll make a new suggestion for a day to talk with you and David to maybe get a joint effort in this specification or a version of the specification from Steve with your solution.
Great, thank you for that.
To get that going. Yeah. Any other last comments? Okay. Yeah. With that, I thank you. Thanks for the nice presentations. Thanks for a successful OCP summit. A lot of interest. I think we will have a lot of work, but a lot of contributions over the summer for the global summit, and looking forward to the process. Thanks so much, and take care. Bye.